Though I bring multiple resources together, that's definitely not going to definitely not going to increase the budgeting cost for me, because I'm going to use commodity hardware, which is the cheapest hardware. What's the difference? If I take a particular CPU which I'm trying to use for Hadoop cluster, okay, and which is already there with a traditional or a legacy system like IBM mainframe. IBM mainframe is an enterprise hardware, and let's say a CPU which I'm using for Hadoop is a commodity hardware. So how different these two are? If something goes wrong with the hardware of the mainframe, we'll have IBM team to work on it, because it's an enterprise hardware supported by IBM. And for that, it's not just about hardware cost. You are going to pay maintenance and processing costs on quarterly and on annual basis. So when I aggregate all these costs, it's nothing but it's maintenance cost or hardware cost that will be there on top of your enterprise hardware. Whereas with respect to commodity hardware, you will not have anyone to support your hardware hardware failures, and you have a high proximity for this hardwares to go down, because these are the cheapest hardware available. If I take a cheapest mobile and an Apple iPhone, definitely I will have more trust on Apple iPhone rather than the cheapest mobile I've taken. But is that not a risk to use commodity hardware? No, definitely not, because Hadoop architecture has master slave architecture, who would take, and the masters would take the responsibilities of the slave's failure, and as an user you are least bothered about these failures which you can expect from commodity hardware. So going back to our example, rather than having 100 workers to lift, rather than having one resource to lift 100 bricks from place A to place B, I've taken 10 people. Because it's a commodity hardware, I will take 20 people and I'll have 10 people in buffer. Okay, and if any of this particular particular worker has fallen sick, I'll bring one more resource from the reserve bench and I'll use him. That's how your Hadoop architecture is designed. And we can take care of that failure later on, because I already have plenty of resources. Everything is cheap. Let me use it, and any failures I'll deal with it later on, or admins can take it. Okay, an intervention is required. If it is a power shutdown or a port communication failure, it can be anything. So let admins take the job, and there will be no halt to your processing that you are doing on top of Hadoop. It would be resumed, or it would be continued as it is. The only thing is few hardwares had failed. Let it fail. I have reserve bench. I'll use them. I'll ask them to complete the task. So that's how you are able to deal with huge data sets in a distributed manner. And again, on top of that, we have a cost-effective hardware, which is commodity hardware. Which is commodity hardware, right? So any questions now? So at least after attending this demo, everyone should be in a position to explain a layman on what Hadoop is and how advantageous it is in distributed processing of larger data sets. Yeah. So I think it's good with everyone. If you have any questions, I'll take it up now.
What are you hearing? Daddy, what are you hearing?
Okay. He's using Hadoop. He's using Hadoop demo. Okay, fine. Let me talk about how we are going to deal with this course and what are the primary objectives of this course. I've already told you the takeaways from this course would be you should be in a position to independently work on Hadoop developer part. So what precautions are we taking for this? So at the end of every section or every component, right? Because probably you might have already read about Hadoop. Hadoop has MapReduce, but on top of it, it has its ecosystem components. When I say ecosystem components, they are the family of Hadoop which allows you to process the data sets again. Because Hadoop is an analytical repository, right? When you have analytical repository, what you do is you store big data, and which is nothing but some historical data, and you try to analyze on top of it. And it's not just about MapReduce. You also have the components of Hadoop which allows to do this. Okay, and at the end of every component, after the practical sessions of every components, you are required to work or complete a case study which gives you hands-on on, let it be MapReduce or the components of Hadoop. So what are the components that we are going to deal with in this course? It will be Hive, Pig, Scoop, HBase, Flume, Oozy, Impala, right? And on top of this, we are going to deal with the architecture of Hadoop. We are going to deal with the most advanced architecture of Hadoop, which is 2.0. But before that, we are also going to deal with 1.0. And after this architecture, we are going to talk about MapReduce, right? And when it comes to MapReduce, there are two versions of MapReduce, MRv1, MRv2. So we are going to develop the components on top of MRv1 and MRv2 as well. So let me walk you through the course contents that we are going to perform or we are going to deal with in this course. Okay. So, like I told, we will start with Hadoop 1.0 architecture. I'm sorry, one second. Yeah, we are going to start with Hadoop 1.0 architecture, where we'll talk about all the networking concepts and all the communication protocols of different daemons on top of Hadoop. Okay, daemon is nothing but a service provider which runs in the background. Okay, we have 5 such daemons in Hadoop architecture. We are going to discuss about that. And then we are going to talk about 2.0 architecture, wherein we will see what are the limitations of 1.0 and what advanced features we have in 2.0 and how architecturally 1.1 and 2.0 are different, and how come Hadoop is able to work with both 1.0 and 2.0 at any single point of time. How is this possible? All these possibilities are something that we are going to discuss in this architecture discussion. Next comes to the prerequisites for any Hadoop developer or an architect or an analyst. There are two important prerequisites for Hadoop. One is Linux and another thing is core Java. I'm repeating, it's just core Java, not all the frameworks or different things in core Java and different things in Java. It's just core Java. So why Linux is required? Again, coming back to the example, HDFS. It's a file system, right? It's nothing but that distributed file system is composed of either Linux or Unix or CentOS. So when you have your file system built on top of Linux or Unix or CentOS, it's important for us to learn Linux. So we will deal with Linux, but I'm not telling you that I'll take a separate sessions on Linux, because please understand that I'll have to talk about different components here. All these are something that we'll have to cover. So what we will do for making you comfortable on Linux is, or either core Java would be, I will take about 8 to 10 sessions to complete this architecture part. When I'm talking about architecture, it's something purely theoretical, or architecture discussion we will have, and you'll not have any case studies to perform here. So this is the best time that I'll utilize every day after the session. Okay, of course, after the day one, I'm gonna share you with some tutorials and videos of mine. You got to watch that for 1 or 2 days, and after that, and from starting from the third day or fourth day, I'll give you the case studies on Linux and core Java. So before or by the time we end up the discussion on architecture concepts, you should be, every newbie to a Linux or core Java should be comfortable at least with the basics of Linux and core Java. So I'll be utilizing the time when you have during the architecture discussion. And I listed Python also here, but it's not a prerequisite, it's an add-on. If you are already from a high-level programming language background, it's a cakewalk for you to understand Python, but I definitely don't say it's a prerequisite, it's an add-on. Okay. And coming to the cluster installation, because you should have your own cluster to practice. When you are talking about Hadoop and this course, it's totally about analytical things. You'll have to analyze different data sets. It's not just about taking the sessions and going away. It's about having some hands-on. So you should have your own cluster. It can be a single node cluster, which is called pseudo node cluster, or an multi-node cluster. We will build our own cluster. I'll start with the pseudo node cluster. We will install it, because you can ask me, hey, installation would be an admin task, right? Why are we doing this? It's because I told you that almost like 8 to 10 days I'm gonna talk about architecture. Almost like 8 days. I cannot take it for 10 days. Definitely for 8 days I'll talk about architecture. When I'm talking about architecture, there are a lot of internal configurations I'll talk about. So when you install your own cluster, you'll be able to understand what those configurations are and how you are going to tweak the properties of Hadoop and stuff. So that's why I will take 1 to 1.5 hour session to install the cluster, and again at the end of every section you'll have your detailed documentation, right? And then after installing our cluster, we will get some hands-on on our file system, which is nothing but HDFS. We will talk about HDFS on all the commands that are available, and of course we'll have some case studies like automating some tasks on top of HDFS using Linux. And let me tell you, HDFS and Linux are almost same. The commands of HDFS and Linux are almost same. I'm not saying everything is similar, but almost same. So again, that would be advantageous for us when you learn Linux, that would benefit us during HDFS commands. And from here on, you will have a case study to perform after every section. Then the most important thing, MapReduce using Java. Java is the highly preferred programming language for writing MapReduce, because Hadoop is a framework which is built on top of Java itself. So we are going to deal with core Java for MapReduce. When it comes to MapReduce, it's not just about mapper and reducer. There are a lot of internal things in MapReduce. We are going to discuss from ground zero to a high level of proficiency on top of MapReduce. We are talking about the optimizations. We'll talk about some compression techniques. We are talking about different ways of analytics using MapReduce, right? So all these phases of MapReduce will be discussed in this particular MapReduce section. At the end of this particular section, each individual should be in a position to write a logic on top of MapReduce using Java. Of course, you'll work with few case studies as well, but let it be, it's not just about this case study. Any case study I give you, you should be in a position to work on that. And I'm going to talk about streaming as well for a couple of days. It's because MapReduce using Python is nothing but for the people who don't know core Java. But again, in this course we are also talking about core Java. But for the benefit of the people who might end up working in Python, I'm going to talk about MapReduce using Python. That means which is nothing but streaming for a couple of sessions. Okay. And then comes the components. I told Hive. What is Hive? Hive is a data warehouse on top of Hadoop. I mean, if you know what this name suggests, like Hive is nothing but honeybee's nest. Okay, and if you know that honeybee's nest is so structured that everything would be placed right after the other. So even Hive is something which will be able to deal with structured data. There are three types of data available: structured, semi-structured, and unstructured. And Hadoop, I mean, big data is nothing but it's a combination of structured, semi-structured, and unstructured. Hadoop is pretty well in dealing with all formats of data, but Hive will deal with only structured data because its architecture is designed in such a way that it will be able to deal with only structured data. So that's why they have given it as Hive, which is nothing but honeybee's nest. Now, that's one of the ecosystem component of Hadoop. We are going to talk about Hive in very much detail. And then comes Pig. Pig is a data flow language, and it's no different than animal pig. It's because if you know that animal pig can live everywhere, can eat anything. Similarly, this ecosystem component Pig will be able to deal with structured, semi-structured, and unstructured data as well. That's why they have named it as Pig. Pig is something which has its own Latin called Pig Latin, which was developed by Yahoo, right? And it's specifically designed for dealing with all formats of data. So that's about Pig on a high level. So Scoop. I was telling you that we will be doing analytics. But without data, how can you do analytics? You require data. But for the organizations who has their data warehouse on top of RDBMS, you'll have to connect to RDBMS and take the data into Hadoop, right? So Scoop is an SQL import and export utility. It's not an animal name. It's an abbreviation. SQL import and export utility. It is primarily designed for importing and exporting data from various data warehouses. Next, okay, how about organizations which has data over their web servers or in different file systems? Because Scoop is only for an SQL part, right? RDBMS part. How about for file systems and web servers? You will talk about Flume. Flume is something which takes the data from different file servers or web servers using its configuration files. Next, if you look at any job profile, right, probably you search it in LinkedIn or any social, professional networking sites, they would be asking for the combination of Hadoop and a NoSQL. The NoSQL can be either Cassandra or HBase or MongoDB. So I'm literally going to talk about all these architectures of NoSQL, but my primary concentration would be on HBase, which is one of the NoSQL family. NoSQL is nothing but not only SQL, right? It has column oriented, and it deals with some structured and semi-structured data. So HBase is a versioned column oriented database. I'm going to talk about starting from architecture to the CRUD operations of HBase. Okay, and finally, I'm sorry, I have a sore throat today. I'm not able to speak properly. I'm so sorry about it. We have a scheduler as well, because we are dealing with a lot of ecosystem components like Hive, Pig, HBase, Scoop, Flume, and then we have our algorithm called MapReduce. So how are we going to schedule all these things? For scheduling this MapReduce or ecosystem components, we will use Hadoop inbuilt a scheduler called Uzi, which is developed in India in Bangalore, or we can also use Autosys, which is Computer Associates a free versioned scheduler. Any of these two schedulers or any other schedulers like Mastro, or you can use Control M, or you can use TWS. You can use any of these schedulers to schedule the jobs of Hadoop. I mean, anything I've listed here is a scheduler. It's matter of just understanding how you schedule the jobs, which